So let's talk now about interface policies and profiles. So again, from this model, we're going to be looking now at the interface policy, policy group, profile, and interface selector. So the first thing that we'll do is we will, and it looks like I seem to have either hidden or missed a slide, where we can go in and set our individual policies. But again, they're not too interesting. They're things like, are a link level policy set hard-coded to 1 gig, or auto negotiation, is CDP enabled or disabled, is LLDP enabled or disabled. And by the way, the Fabric default is CDP is disabled and LLDP is enabled. So once we've defined our policies, we would then right-click on policy groups and either create an access port policy group if what we were going to apply it to were only ever to be used for an access port, a PC if we were going to do a port channel, and a VPC if we were going to attach it to a virtual port channel. We would give it a name, possibly a description, optional, and then specify whichever policies we want to incorporate and have different than the default. If we simply omit a policy, it goes to the default. From there, we can take a look just by clicking on and seeing all of our policy groups, and really it kind of enumerated all of their settings. From there, next, under interface policies, like I said, we always have this 3-tier architecture. Policies go into policy groups, which get attached to profiles. And notice these are all a subset of interface policies. By the way, a quick word of caution, or just kind of a preference that I have and something that I highly recommend that you do, is do not expand all of the left navigation folders unless you know that you're going to, first of all, unless you are very familiar with ACI, and once you get very familiar with ACI, you can expand them more and more. But even then, sometimes they kind of blend together after you've been working for a while, and even then, sometimes I can get confused. So I like to typically leave them collapsed and only expand the one that I want. Otherwise, I might see profiles or policies or policy groups and right-click and try to create something and it doesn't work, and that's maybe because I was under module policies or switch policies or global policies instead of interface policies where I wanted to be. So then we can create the interface profile, and from there we specify the interface selectors. So for instance, this interface profile is called GigE servers, and so the idea is that this profile is not just for one interface, but it's for multiple interfaces, and the interface selector or ports are going to be 1/1 through 10. Now keep in mind, unless your leaf switches are the modular 9504 or 9508 switches, then your 9300s are always going to begin with 1/. When you get into the modular switches as leafs, when they're supported, you might have things like 2/, 3/, 4/, for blade 1, 2, 3, and 4. And then from our access port selector, this is where we attribute our interface policy group, okay, that we had created before. So now all of these policies in the policy group called GigE servers would be applied to all the ports, 1 through 10. But on which switch? There's no place in these web user interface that we see, at least, to specify which switch we're talking about. That's right, there's not. It's completely abstracted. And this might be either A, the maddening thing for you, or B, once you come to realize how to design with ACI, the most amazing thing. Because again, let's say I only attach my GigE servers to ports 1 through 10 on any leaf switch. I designate that any leaf switch in my fabric, except for maybe an exception pair. Maybe I've got a pair of switches that's only used for border leaf external connectivity or something else. Maybe I have another exception. I can always have exceptions. Okay? But I designate that port 1 through 10 on any leaf switch, 100 leafs, I don't care. Port 1 through 10 is always going to be GigE connected servers. I go ahead and create this interface profile that specifies Gig E servers, and I note the interface port selectors are 1 through 10. And then I apply this to a switch profile which contains the switch selector or the specific switch leaf switch nodes. And it's all of them except for my border leaves. Then every leaf switch immediately on port 1 through 10 has CDP disabled, LLDP enabled, and 1 gig E hard-coded, full duplex, and any other policies that I wanted to create. Now, what happens if I did that? And you might say to yourself, all right, that sounds good, Mark, but I can't always guarantee you that port 1 through 10 is going to be on a particular leaf switch, or is going to be a Gig E connected server on a leaf switch. I might plan that way, but at some point I might run out of ports and I might need to use port 8, 9, and 10 on leaf 39. Okay, not a problem. When that day comes, you can create an override policy. So you've already deployed your interface profile on all your leaf switches. So 1 through 10 is already set up for Gig E, only hard-coded. But a day comes, maybe tomorrow, whenever, that you need ports 8, 9, and 10 on leaf 39, or some other exception, or a few leaves, to have something different. So that is where you can, at that point, go ahead and create an override policy and override those ports to have your new specific configuration, your new specific policies. So it's not the end of the world. By the way, if you're working, and I'm going to kind of note this throughout the whole course, all the modules, it's very likely that if you're watching this early on, right after I recorded this here in June 2015, that you probably still have a number of clients, or possibly even what you're working with in your own internal network is a little bit more legacy. It's not quite the most recent release of 1.1. Brahmaputra was the code name. So which just got released in June 2015, midway through. If you are one of those people and you're working on that, the override policy is a feature of the new 1.1 Brahmaputra. So you do have to be running the newer code to take advantage of that. If you're running the older code, that's not a feature that you have available to you. So I'll point out those features that are only available in the newer code as we go along. So here's the interface policies. It was just a misnumbered slide. I must have, when I was editing my slides, must have drug it in the wrong order. So this really should have come first. These were some of the interface policies, and there are some newer ones in our 1.1 release of Brahmaputra, such as the MCP protocol or miscabled protocol. We'll talk more about that in relation to spanning tree a little bit later. Specifically on, actually much later, when we talk about external layer 2 connectivity, that's when that will come into play. So look for that a lot later. Here's just an example of a link level policy for auto negotiation on or off. 40 gig for our leaf switches that do support 40 gig south facing, 1 gig hard coded, 10 gig, or 100 meg. And we could even leave auto negotiation on, but just specify what we'd like to see auto negotiated, or we can turn it off for hard coding, as well as a link to bounce interval. So let's talk next about ACI switch policies and profiles. So that's this subsection over here. So this is going to be a very brief one-slide section where we create our profiles. Remember, policies and policy groups, we don't really have to do so much with switches, with the switch policies. And again, that's because we only have a couple major policies or policy groups, which are things like spanning tree, multiple spanning tree, MST regions for TCN. So we create a profile. Now, if we have VPC pairs, we'll talk more about those towards the end of this particular module, then we're going to have just 2 leafs in the profile, and I would name it something like L101 and L102 for leaf 101 and 102. That would be for a VPC. I might also have individual leafs, leaf 101, leaf 102, for orphan ports. And I could even have leaf 101 through 110 and just specify all of them and say I have a single switch profile that has a lot of switch selectors or multiple switches, and all of the leaves or leafs that are there get applied this policy group. And then I simply have to create one profile, and bam, all ports 1 through 10 are 1 gig. But again, I could do it leaf by leaf if I wanted to be that granular, and I'd have a lot more control. So now let's talk about ACI pools and domains. So going back to our logical model, we're now talking about the domain and subsection of pool. So when I take a look at VLAN pools, I can either define VLANs based on, actually pools in general. I can define pools based on VLAN, VXLAN, VNIs, or multicast address, which would be useful for VXLAN flood and learn identification or classification. So we're going to talk a lot more about VLAN pools, specifically as it pertains to dynamic allocation and static allocation. There's not much to be said, but we'll talk about that. So first of all, what's the idea of a VLAN pool, right? I understand a VLAN database, but why a pool of VLANs, especially dynamic allocation? That sounds like we're doing DHCP for VLANs. Well, you could kind of think of it like that. Okay? When we get later in another module to VM networking or virtual machine manager, VMM domains, then in this module we're going to talk about physical and L2, L3 external domains. But in another module we'll talk about virtual machine manager or VMM domains. And basically, here's the real quick gist of it, but I'll go back over it when we get to the next section into VMM. Basically, whenever I create an EPG or an endpoint group in Cisco ACI, if that endpoint group is tied to a VMM domain, then ACI looks at who is the virtual machine manager. If it were if it were VMware, it would be a vCenter server. We might have multiple vCenter integrations, so which vCenter server? If it were Microsoft Hyper-V, it might be System Center. So which System Center? We might have multiple Hyper-V integrations. If it were, something else, KVM, it might be OpenStack or something like that. So we need to know where do we reach out to and create, in the case of, let's just say VMware, the most well-known probably and most widely deployed, we need to create a port group corresponding with every, so a VMware port group on a distributed virtual switch in vCenter corresponding to an ACI endpoint group. So for every endpoint group we create, it will dynamically push a VMware VDS or virtual distributed switch port group. Now, in order to push that, it needs to know what is the VLAN ID. So it dynamically pulls it out of this pool that we assign it. Okay, so that's the idea behind dynamic allocation. If it were over on Microsoft System Center, it would create a virtual network. Okay, the same concept applies. If we're using our VLAN or pools, and we have to create a pool regardless, for a physical domain, then we might just do static allocation. So then after we've defined our pool of VLANs, then we create our physical domains. Now our physical domain, or possibly, and we'll talk more in our layer 2 external and layer 3 external modules, we could have external bridge domains for layer 2, or for layer 3 external, our external routed domain. And I already mentioned the VMM domain, which gets created over here and we'll talk about later. But for our physical domain, we see this under the Fabric Access Policies. We right-click and create the physical domain, and then we tie together the AEP with the VLAN pool and give it a name. So let's talk about the AEP, or Attachable Entity Profile. So here we were just on the page for domain. We created the pool, and then we created the domain and tied it to the pool and the AEP. And remember, this AEP is like the software glue. It tells us where, meaning on which interface and on which switch, we expect to see a given VLAN tied to a particular domain which is what's associated to the EPG. So the EPG is who we have attaching to our fabric. How they attach is classified and identified by the VLAN pool or possibly VXLAN pool at the domain level. And then where they attach is the AEP, the Attachable Entity Profile. So again, we're under Fabric and Access Policies. And on the left navigation, we've already looked at interface policies, switch policies, and we also looked at a little bit further down under pools, under VLAN pool and domains. Now we go to global policies and attachable access entity profiles, or attachable entity profiles. So here we'll create one, give it a name, and then specify the domain, whether it's a VMM, physical, or L2 or L3 external. And then that will automatically populate what the encapsulation is based on the domain's VLAN pool. So then from there, step 2 of that was we can associate that to the interface. So this is where we tie the AEP to a particular interface on a particular switch. Alternatively, we could, instead of going ahead and saying that association, we could just click Finish, and then we could manually go up to the switch profile and link it to the switch, manually go up to the interface policy group is where that is applied, and link it to the interface policy group. So we have either option. So here's a final configuration example of, we've created some interface policies. One is link speed 1 gig and another is link speed 10 gig. We've created one policy with CDP on, another with it off, one policy with LODP on, another with it off. Okay? And then any LACP or statistics or anything like that. We've created 2 policy groups, one with link speed 10 and CDP on, another with link speed 1 gig, CDP off and LLDP on. Then we've gone ahead and attached or created an interface profile with an interface selector. So 1/10 through 15, as well as interface selector 2/5, assuming we have a modular switch. And then we have another interface profile with 3 very specific interfaces, 1/23, 2/13, and 2/20. Then we have 2 switch profiles, switch profile 1, which designates leaf 101, 102, and 104, but not 103. Switch profile 2, which only has 103. We've created 2 AEPs, 1 and 2. And you can see where all these are tying together. And then domain A, which has VLAN 100 and 200. And then domain B, which has VLAN 300. Now remember, in the older versions of code, those could not overlap if they were going on the same switches. But here they're not, right? Here we have switch profile 1 with 101, 102, and 104, but not 103. And then switch profile 2 that only has 103, but not 101, 102, or 104. So in this case, even with the older code, we could reuse VLAN 100 in both places and have it mean something totally different. But like I mentioned, in the newer ACI 1.1 code that we'll be working with, Brahmaputra, we have the ability to use VLAN 100 even if we had overlapping switch profiles, provided that we had turned on PPV or per port VLAN. So how does this push down the logical model into the physical fabric? We see that leaf 101, 102, and 104 applied with switch profile 1 get VLANs 100 and 200 instantiated. Now, as soon as we create the AEP and tie the domain VLAN pool over to the switch and interface, the VLANs get created in the VLAN database on that leaf switch. They only actually get pushed down to the port when we create the EPGs. Now, if we're doing per port VLAN, they would get pushed down to the port immediately because they would not be created in a global sense. And note that leaf 101, 102, and 104 all have interfaces E1 10 through 15 and E2 5, and they all have the same VLANs with the same link speed, 10 gig, and CDP on. And then a separate switch profile 2 with VLAN 300 applied to ports 123, 213, and 220, link speed of 1 gig, CDP off, and LLDP on. So the more you create similar configurations, the more granular or scalable your fabric access policies and the entities that you create there can be, and the more reusable they can be. Now there are some exceptions and things to take into consideration with VPC configuration in ACI Fabric. So let's take a look at those to wrap things up. So there is VPC support in ACI Fabric. There is no, as I mentioned, no dual 10 gig port channel used for the VPC peer link. So the peer keep alive is done through the ACI Fabric, and really there is no peer link. Okay? So in terms of how we get traffic to these leaf switches, and we're going to actually talk a lot more in 2 modules about fabric operations and how traffic is forwarded on the fabric. First, we need to understand how to configure it and what is there, and then we'll talk about how traffic is forwarded. So we will go into those details. Take a look at a per packet flow for VXLAN as well as for VRFs and things like that. And how IP addresses are learned, how ARP is done away with. We'll talk about all that. But one of the things that I've already mentioned is that the loopback 0 is the first interface that's created, and that is your VTEP, or VXLAN tunnel endpoint. By the way, if you see VTEP and you also just see TEP, those are the same thing. Okay? So here we talked about how the loopback 0 is the unique unicast VTEP, but in the case of other leafs, let's say 3, 4, 5, and 6, not pictured here, needing to send traffic over to these particular leaf switches, but we might have one MAC address on one host dual attached with LACP through VPC. So we learn that one MAC address on both leaf switches, and it's advertised out to the rest of the fabric. Instead of using the loopback 0 VTEP, it's advertised out with the VPC VTEP, which is an Anycast IP address. So what that means is a new loopback is created. Let's just say loopback 1 is created on both leaf 1 and leaf 2, which are the VPC peer switches, and it's the same IP address. So MAC address A would be advertised out to the rest of the fabric using the single loopback 1 same IP address on each switch. That way, again, not pictured, leafs 3, 4, 5, and 6 would know to send it to that one IP address. Of course, they would send their traffic to a spine, and the spine would do equal cost multipath, and again, the technical term of eeny, meeny, miny, mo, to determine which, based on the static hash buckets, which switch gets which particular flow of traffic, and then that would ultimately get to the proper host. And then we could have per flow load balancing. So path recovery also happens via the fabric, not the peer link. And Cisco Fabric Services, CFS, is now replaced by AFS, which is a modified version of CFS. So ACI Fabric Services. Okay, there is a multicast forwarding selection. We'll talk more about multicast in a later section. So I already mentioned this traffic within the fabric for a given host attached south of the VPC peers are sent to the VPC Anycast address. Okay, and the hardware flow hashing is between peers, is actually via the spine. Like I already mentioned all this. Okay, if one fails, there is something that's created called a bounce entry. Again, this is something we'll be talking a lot more about in the next actually 2 modules when we talk about fabric operations and forwarding. And MAC and IP to leaf bindings for the specific virtual port channel are removed from something called the COOP database and the spine proxy. Basically things that we haven't talked about yet. We'll go into all of these detail of what these are in 2 modules in fabric operations and forwarding. So how do we configure VPC? Again, it's under fabric access policies. We're here under interface policies, but when we right-click our policy group, we have to tell it not to create an access port, but a VPC interface policy group. Now, this is one thing to note that's very kind of strange, because the idea is that we would have reusable entities, right? If I have gig-y servers, I could apply this to multiple different interfaces or interface profiles. VPC is a little bit different. Why? You just have to ask the developers. When we brought this up to them, they kind of looked at us and said, you guys want everything, don't you? But joking aside, not joking about that, but anyway, when you create a VPC interface policy group, you actually have to create one per VPC. So as you note here, I have ESXi01 VPC policy group and ESXi02 VPC policy group. And as you might imagine, they both contain the same policies for interfaces. But I actually have to create one per VPC. Let's just say one per VPC, one per virtual port channel. If you don't, all of those links, once you apply this to an interface policy or interface profile, all of those links will be aggregated together into a single virtual port channel, which obviously doesn't work. Okay? I won't go into the specifics here of why it doesn't work, but just suffice it to say it does not work. We would learn the wrong MAC addresses on the wrong ports, or actually we'd only learn them on one port channel, but the Fabric might try to send them out any of the ports on the port channel, and they would get to the wrong server, and the server would drop the traffic because it doesn't have that MAC or IP. So we do have to have one per VPC. So in the case of, let's say, this Nexus 5K, CDP is enabled, LLDP is disabled, and LACP needs to be active. And then from the southbound perspective, here's kind of an example. Leaf 103 and 104 on ACI. Port 125 are the VPC peers. And then southbound on the Nexus 5K, interface 17 and 18 are that single channel group 10 mode active. And therein we have, kind of back in ACI, we have that port channel formed. Now there is going to be something special when it comes to creating VPC that goes from 2 leaf switches down to 1 Fabric interconnect, but the device that we're connecting to from a virtual machine manager perspective, when we create a vSwitch, because ACI creates the vSwitch in VMware vCenter, could not have port channeling. So we'll actually go into a very unique kind of exception or use case when we get to the module for virtual machine manager. Okay, and that's how we'll create what's called a vSwitch override policy. But suffice it to say, for physical devices, this is what we'll do for VPC, and this is even what we would do for Fabric interconnects. So 2 leaf switches, leaf 103 and 4 going, instead of a 5K pictured here, going down to a single Fabric interconnect A, and then leaf 103 and 104 from 2 other interfaces, maybe E126 and E126 going down to Fabric interconnect B. That's what we would still do.